Today I will be giving a talk on SOLID, which is an acronym for some of the kind of the most helpful design principles I've really kind of used however much throughout my career. And so hopefully that can help some other parties as well and help with iterating quicker and quicker and help be maintainable here. So SOLID and you, making the change easy. And then authors, yeah, me of course, and then there was some assistance from Opus 4.6, so we got that on there as well. And some links at the bottom in case we want to connect. Let's see. So kind of kick it off with some of the history, how this came to be. I'm sure probably a lot of us have done object-oriented programming, functional, different types. So this is really kind of geared, and while I can translate in different ways to other domains and other paradigms, it's really kind of geared towards object-oriented programming. And so yeah, it was kind of born out of, or amidst the C++ era. C++ came around in 1979, and you start seeing these things come and people coming up with different ideas and how to make their code better and how to iterate quicker, et cetera. So, born from the pain of brittle C++ systems, where a single header change trigger cascading recompiles across the entire code bases. Let's see, so a little bit. So let's see, yeah, so we'll go into those a little bit more here in a second. But basically, yeah, so Bertrand Meyer will probably be more helpful once we dive into some of these here in a second with acronyms. But open-close principle, which will come up, is the O. Bertrand Meyer, 1988. Barbara Liskov, if you ever heard of her, she's like ACM Turing Award winner. But 1987, she first published a paper on the L, which we'll get to. And then there's another one related to that in 94. If you ever read Clean Code, you might recognize the name Robert C. Martin. He really kind of added some other ones into there, like single responsibility principle, dependency inversion, and some interface segregation related things. And then the official term coming in 2004. So now to some more exciting stuff. So, but first, why it still matters. So basically what will happen, we'll learn more about these and see some examples. But when you take the time to really apply these, what emerges is, loosely coupled, highly cohesive designs, which really help to minimize, called the blast radius of change, but as opposed to having to make change in 10 different places, if, you have one issue, one thing change, you have it loosely coupled, it can, kind of helps you be a bit more nimble short of it. Let's see. All right, so the first one, S, stands for single responsibility principle. Some of you all may have heard this, but basically what this is, you want to separate your concerns. Oftentimes you might see code, or in general, it's best practice separating your concerns. So you might see one kind of God class, for instance, that handles, maybe not the best diagram short of it, but basically, God class that handles, it's handling rendering, it's handling sending emails, it's handling aggregating certain data types, So basically, in the official quote, when this was coming around was, module should have one and only one reason to change. So it can be misinterpreted at times, but basically what it boils down to is the idea of a concern. And so, each of these, each of the things I described would represent different concerns. Sending email, one concern. Data gathering, one concern. Rendering, another concern. So you really want to kind of separate those out, and the concerns mapping to responsibility. Let's see, so here's an example. So on the left we have labels bad and good here, but there's different designs, but on the left you have, you might call it a God class, right? In a sense. So, it has those three separate concerns. You'll see the three separate methods. And this is in Python, but let me know, I can figure this might be readable to most of us, so I can translate some of this stuff. But basically, yeah, three different methods there. And, saying, how would you break that out? To help respect or, help leverage single responsibility principle. So essentially, it's breaking out those three concerns in separate classes. It's kind of a contrived example, you might have different inheritance, different things around this, but the core idea is that you're separating out responsibilities. And, so one change, you're not testing other functions within the class, et cetera, et cetera. Let's see. All right, now on to the O. The O is the open-close principle. So like I said, this is from a guy named Bertrand Meyer, around 88, came up with this, or formalized it. The original quote is open for extension, closed for modification. And then he was later reframed. Uncle Bob, who's the Robert Martin clean code guy, framed it more in terms of polymorphism, not inheritance. Just really extending behavior without touching existing code is what kind of develops from this, the idea behind it. So whether you're extending an API, you're not, basically, helps to decrease the blast radius, if you will. And so, for instance, let's see, we'll get to those examples, it'll make more sense here. But basically this is a base class and these are inheriting down here. And so, you might have these in separate files. So say one of these changes, you're not going into this other base class in some way or God class. Let's see, so here's some examples. This is kind of a classic example you'll see in text on the internet if you look some of this stuff up. But say, for instance, you have like a send, right? You're doing different types of send. It's polymorphic in a sense, right? And that polymorphism is represented by these f-else blocks. So again, every new channel, you're editing this file, XYZ, you're amidst this larger context with more chance for breakage, can be more brittle, et cetera, et cetera. Kind of the same themes that apply throughout these in terms of what it helps with. But yeah, so here's an example over here. So you basically have these broken out. You have inheritance. There's some method overriding here for the specific logic. And one thing that'll come up is really all these kind of tie in together in different ways and help shape the designs in different ways themselves. So part of what will come up later is one of the principles. You want to preserve the intent across these. So while these are overrides, right, you're making sure the underlying behavior isn't really changing, even though you're overriding it. So basically you're extending that notification channel class through the inheritance amidst the other class without having to touch that. And so that's kind of open close. But really, one of the most common areas I'll use it, it's like API design, extending a function, say functions within 40 other places in the code, right? Centralized. Well, do you have the time? Do you want to test for regression? Is that most helpful? Okay, let's go ahead and split it off. So it really touches lots of different things, maintaining API contracts, lots of different ways, really. And so, this brings me to the L, which is kind of what I touched on towards the tail there. It's called the Liskov substitution principle. Again, that was Barbara Liskov in 1987. She introduced it in the keynote and then formalized it later in the 94. And so this is a little bit more academic definition. But I think, kind of thinking about it in this abstract way, a little bit more abstractly, and how, how generic of an idea it is and apply to other things can be helpful. So that idea is if S is a subtype of T, objects of type T can be replaced, with S without altering correctness. So subtypes, so you might say, well, backing up, before we get to this last line, so basically the idea is that child classes or base classes can be substituted with similar methods, the same methods, right? Your methods and child classes are inheriting can be substituted without breaking the contract. And that goes to the idea of the intent. So you can still have that method overriding, for instance, right? So it might not do the exact same thing as the base class exactly, but the overall concern and thing it handles is the same. So you're maintaining basically the behavior contract, if you will. Another smaller facet of that, how much change? I'm talking about the idea of, we were looking at the example with method overriding, right? For that send method in the last class here. There, and there from the base class, not the bottom. But so when I was first learning this or trying to understand the heart of it, that this later idea of what constitutes change, in what sense does it modify, or to what degree can it modify correctness, right? So there's the idea that subtypes can weaken preconditions and strengthen postconditions, but never the reverse. And so you're not removing validation on the sending of emails, whereas in the base notification channel, you didn't have that, right? If you substitute the base class, that kind of significantly changes the contract. So there's subtle changes that in her mind's eye were still okay and helpful to make. So here's an example. I know this one, at least for me, was kind of a little bit more dense to kind of think through up front, a little bit more conceptual lift. But here's another kind of classic example so that you might see. So you have this rectangle class, for instance. You have a square class. square class inheritance from the rectangle class, you might think, okay, both of these need area, both of these have dimensions, right? Well, for instance, with the square, right, you have uniform dimensions, constant dimensions. And so if you have this area method just from the rectangle, right, you can have independent values for the width and height. So if you're inheriting this area isn't going to maintain the same behavior, and it's in effect, well, that's the correct one. It's going to in effect be incorrect. And so basically you can't substitute that rectangle's base class method area function for squares. So that breaks it kind of in an inverse sense. Here's the correct way. It also uses method overriding, but maintains correctness for the subtypes. Let's see. And so yes, actually ignore this part. Area more so. All right, moving on. And actually, I apologize. I was going to turn on, see if I can do it real quick here. Questions. Actually, we'll save them for the end. This next presentation, there's a link. Google Slides supports the thing where you can put a questions link up there. But short of it, feel free to let me know as we're going along, too, if anything comes up. And we'll also save some time towards the end. But yeah, so the I, back onto this, the I stands for interface segregation principle. And kind of the core language around that. So no client should be forced to depend on methods it does not use. Let's see. So you have ideas like fat interface, thin interfaces. So yeah, basically whenever you have a method, stay the concern, start expanding. And you're wanting to do emails, you're wanting to do, if we use that other example, right? You want to do emails, data aggregation, connect to a database, whatever it is. And say you have an init method, right? You need to take a port, you need to take the email service, et cetera, et cetera. So it's depending on parameters that are tied almost exclusively to some of these sub-concerns, right? So you don't want to do that is the idea of this. You want to separate and have separate refined interfaces for those. So specifically kind of just taking only parameters it would depend on, for instance, are related to the concern. So let's see. So here's a for instance. Well, the other example gets a little bit better, but basically you had all these concerns in one thing. This kind of, some of the examples I have mapping towards more so higher level, like system design stuff. But basically you have something that handles read, write, delete, compact. You can split that out between a separate, higher level class that's just the read. It doesn't, have to pull in all these things it doesn't necessarily depend on for various concerns. Here's a better example. It's probably a little bit more clear than diagram, but so yeah, for instance, left, it's kind of that same idea of having this God class, right? Lots of the poor examples, you see the monolithic code, and it depends on the context, how helpful that monolithic code versus taking the time to refactor is, which we'll get to. But yeah, for example purposes, you have that read, write, delete, just in the data store class, and so inherently, so for this example, to translate it, to how this is set up. Basically, a consumer is depending on a class. Say it's a consumer that's just concerned with reading, right? You're pulling in this data store class. It knows about writing. It knows about deleting. You're potentially pulling in heavier load of methods within the class. So really, you can separate out these concerns, split it up, have more refined interfaces. Sorry. Let me know if I'm not talking loud enough here at any point. You can't hear me. And can repeat. So yeah, on the right, you'll see those broken up. And so, it's however much more atomic, this can be pulled in lighter weight fashion. It helps stay more nimble. Let's see. So on to the D. This is probably one. Some of these I'll keep in mind more than others and will come into play for me at least more than others. But this and some specific variants of this, namely dependency injection or some, is kind of some of the more helpful, more used styles that come out of this for me at least. But so the more abstract definition of this, high-level policy should not depend on low-level detail. Both should depend on abstractions. And so, that helps make everything else testable, deployable, swappable, lots of dependency injection with testing, introducing a mock data store versus a repo, injecting that into the init function for whatever's interacting with that data. And so these are some diagrams that try to represent that. So the order processor is directly dependent on these more concrete interfaces. more concrete classes versus having an interface contract and being able to plug in whatever. So that's just the adapter pattern if anyone's used that. So generally just a layer, and then underneath that layer, it knows how to handle the various implementation details, whether it's interacting with Stripe data or Postgres, et cetera. Excuse me. But still has the same method contracts like read, et cetera, on that abstract interface that sits in between with the dotted lines. So let's see. So in practice here. So let's see. I should get a recap back up on this. Okay, so yeah, basically this is the idea. Here you're depending on these concretions, right? So what happens when the database provider changes? What happens when the payment provider changes? What happens if you want to test these? How do you put in a mock client, right? Well, you can use dependency injection, and you can code this to an interface, right? In that interface, so whether you have this Postgres client, right, and this client, both of those are coded the same interface. So you can inject those, or basically add more similar things. But basically the idea is you code an interface, and then it's just provider agnostic, right? So you inject in data store, and that knows the underlying class behind that interface abstraction that sits on top of the underlying class knows how to integrate with Postgres, whereas the parent class doesn't. And so you'll see it broken out a bit more specifically here, like the idea is a payment gateway versus Stripe, et cetera, et cetera. So basically it's the idea of having, it's kind of like the adapter pattern. You have a abstraction in between the two concretions, basically. Let's see. All right, so getting towards the tail, probably a good amount of time still, so time for questions if there are any. But kind of the bigger picture and kind of pulling it together a little bit more. And this is me. So I did map it to some, like I was talking about, some higher level system stuff, because it's not just code. You consider the idea of microservices, right? Single responsibility. Is it helpful to break things out into microservices at all levels, at all like company sizes? Of course not necessarily, but same kind of idea applies. Open close, talked about extending APIs, extending functionality. And so, feature flags, you're keeping it contained. And so that's, flip it on, that extends the functionality. So that's technically a form of that as well. API versioning contracts, methods from V2, the same method that's introduced there, that was available in V1. You don't want to break that. It might be quicker, et cetera, but you might, in that case, or in the case that change its core behavior, introduce either a separate method, deprecate that one, or breaking change, represent the breaking change through semantic versioning. Interface segregation principle. One example here is just best practice separating read-write APIs, and I know keep qualified, but this really does kind of course depend on the return you might get at this at different scales. Hexagonal architecture, if anyone's heard of that, that's basically like architecture pattern for web apps, for instance, where like every concern, it's usually modeled by like a hexagon, but every face of the hexagon is a different concern, and that's just it's inverted dependency. So it's just inherently using that adapter pattern for plug and play, whatever type of concretion. Let's see, but also dependency injection for testing, et cetera. Using mock class, that's where I've really used it mostly. You can say solid is about minimizing the heart of it. My head, solid's really about minimizing the ripple effect of change. That's, the idea of how many places you have to change it. How many things come into question, whether it's still working after you do it. Of course, want to have it tested exhaustively, but don't have to worry about that as much if you have more fine-grained changes, more isolated changes. Let's see, so I've talked about this however much, the idea of when to apply these principles. So I think, big idea in software engineering, something at least later in my career that became more of a thought, as you get it more out of theory, or it's like kind of, merged out of more academic stuff into theory and more practical thinking around it as relates to business stuff. But, it's like, what's the ROI I'm going to get on this? Am I writing a personal script just to do some stuff that I'm never going to have to come back and change? How much churn is there going to be on this? So really, in practice, like when I'm working somewhere, working on a project, say new requirements come in, et cetera, you need to build something, how much, how highly abstract, how much you want to apply all these principles, to what degree, to keep it as kind of like a Rails monolith, help iterate faster, smaller team? Do I break it fully out into microservices? Do I break my classes out? Do I still keep all the classes? Just to have that God class like I was talking about. So really, I try to think about, is there near-term change expected to this facet of the program, or that set of concerns? If not, you usually want to extract as much. Also take into account, just really generally near-term change. I was about to say, how many times is coming back to it, but same thing. Opposite. Pull myself together here. So near-term change can make it a little bit more adaptable. Long-term stuff, pie in the sky stuff, you're not thinking about as much immediately. The team isn't. You might not invest as much of this if you're not going to, if you're not coming back to change it, you don't really reap the benefits of having to make fewer changes when the concerns change. So, there's not necessarily as much of a point because you don't really reap that investment, right? If you're not going to have to ever iterate on it. But there's also a related idea like, you ain't going to need it. Those aren't enemies, so, you don't just need to sit there and say, I don't need this right now, et cetera, but you can balance those and take into consideration, like I'm saying, how much expected churn is there on the software, how much change expected, et cetera. Let's see. And so here I had apply solid where the cost of future change is high. All right, and here's another summary. Here's a little bit lower level. So the S, again, is one class, one actor, one reason to change, single responsibility principle. The O, open-close principle, extend behavior by adding code, not editing it. L, the Liskov substitution principle. Subtypes must honor the base types contract. And then I, clients should only depend on what they use. And the D, depend on abstractions, not concrete implementations. Let's see. So I also have some resources down here. There's really a good amount of stuff across the internet. It's kind of been around for a second and had become, however, popular kind of over the years, seemingly. So short, it can typically find a good amount of content if you're looking up other stuff. But any questions? I know it can be a little dense. Might not explain some of it best, but all right. Well, I appreciate it. Just let me know and feel free. Let's see if we can get these slides. Question? Sir? Sure. I know that's... Yeah, for sure. for sure. And that's definitely why I try to come in and qualify, I know, for instance, myself, early in my career, it's like, okay, just apply these in a vacuum, right? It's like, I'm going to wildly abstract this, every smaller concern. It's breaking out and everything. It's like, no, that's not helpful. Are you going to be coming back to these? Are they going to be expanding soon? Maybe more so. But, so it's easy to kind of, I think, view it more in a vacuum than as the practical application. Like, how meaningful is it for the business to do this, basically? So, for sure, myself included when I was young. But we'll see. I'm sure I'll get with the organizers, see if we can get this. Yes. Oh, I love it. So much of his stuff, for sure. I love you. No, love your fan too. Yes, agreed. And I know Robert C. Martin had some controversial stuff maybe at one point, but in essence, his academic stuff, the ideas, I don't know if that's still a thing, but however many years ago. So just to qualify that, don't agree with those, but some of his code stuff's pretty good. I'll get with the organizers after this and see if we can, if anyone wants a link, go back afterwards. I'll make sure, that's available. But thank you so much again. I appreciate it.